In this lesson, I'm going to show you some examples that continue our work with proportions. And I'm going to give you an opportunity to pause the video at times again so that you can think about these questions and sort of treat this like a classroom as well. So for question number one, it's a book called Outliers, written by Malcolm Gladwell, where I noticed in this chapter of a book, he was talking about an observation that was made by, I think they were parents or coaches, about this list of players from the 2009 Canadian junior team. So in this roster of players, I mean, there might be several things that stand out to you, but pause the video and see if you can see what these coaches or parents noticed about this roster of players that seems unusual. And if you can't figure it out, that's fine, but give this list a look and see if you can find the same strangeness that they found in the data. All right, did you have enough time to think about it? If you did take a look at it, you may have noticed that there's an overwhelming number of players that were born on this elite level team, born in the early part of the years. So we see a lot of January birthdays, February, and March in particular stand out. And this roster has 20 players. 9 of the 20 players are born in either January, February, or March. So 9 players out of 20 players. That's 45% of the team. Almost half the team were born in the first 3 months of the year. Well, what percentage of the team should have been born in January, February, and March? Well, January, February, March makes up 1/4 of an entire year, so it should have been a quarter. So my question to start us off with today is, it's not 25% on that team. It's a lot higher. And is that percentage much different than it should be, or much higher than it should be? So we can set it up with a hypothesis test. Again, you can pause the video and write down what you think the null hypothesis and the alternative hypothesis will be. And when you're ready, unpause the video. So as mentioned, the percentage that were born, the percentage of people who are born in the first 3 months of the year is 25%. A quarter of birthdays should be between January and March. But alternatively, it looks like this list right here, hockey players, is showing more than 25%, much more than 25%. In fact, 45%. So if we're going to continue on with the hypothesis test, we need to do some things in the second step. Pause the video and give yourself a chance to write them down, and then unpause it and see if you got the same thing that I did. So the ingredients that I need here to make a nice presentation here is a nice complete presentation is to name the test that I'm using, a 1 proportion Z test. Check the conditions. Is it a simple random sample of hockey players? No, these were players that were selected to be on the team, the top players from Canada back in 2009. And some of them are Sabres, former Sabres. I see Tyler Myers here, who won the Norris Trophy for best rookie defenseman, or just the best rookie of the year, I guess. Or it wasn't the Norris of it. It was the Calder Cup for the best rookie of the year. I see Jamie Benn from the Stars. I think Jordan Eberle used to play for the Sabres briefly. Tyler Ennis was our captain. Cody Hodgson had a short run here. And, of course, John Tavares, who plays for the Toronto Maple Leafs. So many of these players are still in the league 11 years later as I'm recording this. So, all right, so it wasn't a simple random sample. Now, do we have enough in our sample? Well, we need at least 10 that would be born in the first 3 months of the year. So if 25% is what it should be, 25% of 20 is 5. So there should be five people on this team, or 5 men on this team that would be born in the first 3 months, and that's not greater than or equal to 10. So our sample size is too small. Darn it. So we also have to figure out for the percentage that wouldn't be born in the first 3 months. So if 25% would be, 75% are not. So that comes out to be 15 players. So that's good in terms of the sample size there. If you're really tangled up on these 2 lines right here, don't get yourself too twisted up about that. It's just some nuts and bolts of statistics there. But anyways, we'll move on from there. So the last thing is to set the significance level up. I'll shoot for 5%. You may have picked 1%. Continue to go on with step number 3, calculating the z-score and the p-value. See if you can do it without me. Keep in mind that this is going to tell you which direction your shading should go. Your shading should be to the right. So just as I said, the shading should be to the right, which means that our z-score is going to end up being positive. So placing the numbers into the formula for z, 45% of our team was born in the first 3 months. It should have been 25%, and placing that 25% into the formula below ends up giving you a z-score of about 2. Graphing that on a normal curve is quite simple, and calculating normal CDF can get you your p-value of about 2%. Now, if all of that was too much for that third step, remember you can always go to Stat, Tests, and choose the 1 proportion z-test, typing in the percentage from the null hypothesis, which is 25%. It's asking for x. It's not asking for what percent. It's not asking for p-hat. P-hat's over here on the calculator screen. X is how many were actually born on our team in the first 3 months, which was 9. How many players were there on the team total? There was 20. And you can see we're getting exactly the same z-score as I did in the video, on the video slide. Although that percentage doesn't look familiar to me, 4%. Thought I had something higher or lower. Let's take a look. Let me go back to the original slide. Well, there it is. That's why I didn't get the right match here, is I wasn't paying attention to that last little bit right here, which make sure that that is matching your alternative hypothesis. We should only be shading to the right. Did I make that question? Did I do that question wrong on purpose? You'll never know. You'll never know. Yeah, that was done on purpose for sure. So the shading should go to the right, which gives us about 2% for our p-value. Comparing that to the significance level is the last bit. So we can just quickly jot that down. So in that 4th step, you can say that the p-value is low. So you're going to reject the HO. So it appears that the HA is correct, that for some reason, this team is very heavily born in the early months of the year, January, February, and March. So they've noticed that happened with a lot of elite teams when it came to especially Canadian teams. And so what's up with being born in the winter? Does that give you an advantage to make you a better hockey player? So if maybe you've already read on to the worksheet already, but some of you do not have the sheet because you were just tuning in on the internet. You're my students away from the classroom. So Gladwell's argument is that the Canadian hockey-born players are more likely that were born in the earlier months of the year are more likely to develop into top-level talent, and it has probably much to do with the fact that if the players are older, as they're younger, they're more likely to stand out. And if they're more likely to stand out, the coaches notice that they're much better skaters than their younger teammates. So since the Canadians actually, like in any younger sports league, they have a cutoff in terms of when people can actually join the team. So picture a 7-year-old skating with a bunch of 6-year-olds who might be all on the same team. The 7-year-olds, the players that were born in January, February, March, are stronger, more coordinated, will listen more carefully to the coach, be able to follow the drills more properly, and just be stronger skaters, and maybe just having another extra year or even 10 months of skating makes them much faster. And since they're standing out, they're more likely they can even be stronger and taller and heavier, and all those things do pay quite a big difference when it comes to how good a player might be. And that's going to be very encouraging for those kids. Those kids are going to be more likely to want to stick with it compared to maybe a younger player who is not doing so well because they can't keep up with their older teammates or the older kids on the ice. So all those kids will continue to who are standing out, are going to continue to get better and better and want to get better and better because they're showing some talent. And some of that talent is based on, of course, extra things like they're practicing, and maybe their parents or older brothers and sisters get them on the ice. But much of it has to do with the fact that they are standing out and getting more and more developed and excited about playing the game. So I forget how I have this next slide right here. I think I'm just going to give you a little sneak preview at the start of this one, but maybe not take you through the entire thing. So in the last example, our sample size wasn't big enough. We only had 20 players and the conditions weren't met in that second step. So I decided to investigate a little further myself and found this information out for the decade between 2000 and 2010. I found that in that time in the NHL, there were 1,177 Canadian-born hockey players, and 324 of those players were born between January and February 31st. So in a very similar way, I'd like you to try to calculate the p-value there and answer the question, does this data suggest that earlier birth months of the year predict future professional success? So pause the video and try it yourself. I'm not going to give away the entire answer, but just the start of it. When you're ready to continue, just unpause it and hit play. So to begin, that's my hypothesis test. My hypothesis statement started right there. So it should be about 25% of them born in the first 3 months of the year. And my percentage from the sample ended up being 324 over 1177. So around 27.5% was my sample percent, or my sample proportion. And since that's above the 25%, I will set up my alternative hypothesis to say that maybe the percentage of those early birthdays in the year are maybe it's actually greater than 25% in the NHL. And you can continue on with that hypothesis test, and it's quite similar to the one before it, but better because it's involving a bigger sample size. All right, once that's done, you can actually attempt that third question, which brings it into a, sports is all well and good, and, trying to understand the world is very important, but sports is not exactly the most important thing, of course, in the world, and it doesn't exactly affect everyone's lives, but one thing that does is your schooling and your academic success. So you can try that question as well. And I will not do any of that for you except just to show you the question and wish you good luck. Continue to work really hard and getting closer and closer to the end of our course. Um, we only have a couple more. Well, just one more. Actually, just one more hypothesis test to show you coming soon. So that is it for today. Good luck.